are so fortunate as to, like Ian says, live in a town where all roads lead to Ely. And part of what that means is that we get to learn from people like Dr. Lee Frelich, who's got his PhD in forest ecology. We have actually met him before. Most recently, he gave a presentation a few years ago on tree mortality in forest fires, which was fascinating. And I actually remember shortly after that, I was driving some guests back to the airport in Duluth. We drove through the Greenwood fire, and I was explaining to them about high intensity burn versus low intensity burn and all of these things. And they were like, why do you know all this? I was like, because I attend Tuesday group. Dr. Frelich has authored 210 publications with 332 co-authors from 26 countries. And that's the kind of education that we get to receive here in Ely for free, and just the cost of an optional lunch if you're interested. So we are so fortunate, and some of his major works were published by Cambridge University Press and Oxford University Press. And I myself no longer work in academia, but I know that that is fancy. Okay. So we are very excited to have you here, Dr. Frelich. Please join me in welcoming him to the podium.
Hey, thanks everybody for inviting me back again. I was sure I'd never get invited again after last time. We had to hear all those details about why trees die. And today I'll tell you all about why a whole forest around the whole world might die. But anyway, the future of boreal forests. And I developed this presentation because a group of scientists from all around the world published this book earlier this year. Oh, it says no print version yet. That's not true. It came out since I made this slide, but the Future Forest book, and it covers tropical forest, temperate forest, boreal. I was assigned to write the boreal forest chapter, and they said it should be 8,000 words. And I turned in a manuscript with 13,000 words, and the editor started arguing about me saying too much. And I said the boreal forests are bigger than other forest types, and I should get more space. And the editor agreed. So all 13,000 words are still there. And that's my chapter, Boreal Forests. And when you're chosen by a publisher to write a chapter, you get to invite the best scientists in the world to be your co-authors. So I chose Jill Johnstone, who quit her tenured job at a major university and moved to an off-grid cabin in the Yukon in northern Canada, and connects to the world with her satellite dish. And is still one of the most brilliant scientists around. And then Timu Kulovainen, who is the premier forest ecologist in Finland, but knows all about Finland and Russia and that part of the world. So here's the boreal forest looking down from the North Pole, down on the Earth. And you see from northern Scandinavia there, all across Russia, and from Alaska all the way across to Newfoundland, and the stars where Minnesota is. So we're right on the southern edge of the boreal forest here in northern Minnesota. So it's the coldest forest in the world. It goes from the tundra on the north to the temperate forest, which would be maple, oak, and basswood, or grasslands on the south. And just to give you a feeling for it, this is Scots pine forest in Finland. It actually does not look a whole lot different from red pine in Minnesota, which is a related species. And this is Norway spruce in the Komi Virgin Forest in Russia, which is a 5 million acre forest that has been set aside as a nature reserve, and all 5 million acres never logged. And here's a Norway spruce forest along a river in northern Sweden. And this is mixed wood in the central part of Canada. We also have this in Minnesota, birch, aspen, spruce, and fir mixed together. Mixed wood boreal forest is common in Minnesota, as is pine, jack pine boreal forest, and other types of forest. And then here's young birch and aspen forest. There are large areas in northwestern Canada where the boreal forest is all birch and aspen. And finally, black spruce in the boundary waters in Minnesota. We also have that forest type here. So what's it going to do in terms of summer temperature in the future? We don't know exactly, but this gives two scenarios from the beginning, middle, and end of the century that we're in now. So that on the far right there is 2070 to 2099. And for a high emission scenario, in other words, business as usual, it would warm up about 12 degrees Fahrenheit during summers here. And that would make summers in Minnesota or northern Minnesota in the boundary waters similar to what they are in the southwestern corner of Minnesota or even the northeastern corner of Iowa. Whereas the low emission scenario, if we actually followed one of these agreements that we've made, it might only warm up about 4 degrees Fahrenheit, and that would make the boundary waters more like Grand Rapids. So that kind of brackets the range of possible futures, which, because we don't know how people will behave and in reducing CO2 emissions, all I can do as a scientist is give you a high and a low potential scenario and say what actually happens will be somewhere between. And here's what would happen for that high scenario. So you look, this is a map of balsam fir abundance in the upper map right now. And the red colors means high abundance of balsam fir, and northern Minnesota is very prominent there. That should not surprise you. And that's what it would be in the lower map for the business as usual scenario. In other words, it would be almost completely gone. And the same would be true of black spruce and paper birch and other species. So we would switch out these tree species, black and white spruce, balsam fir, paper birch, aspen. What do we have? Oh, red pine, jack pine here. Those would be replaced by these species: bur oak, elm, basswood, red oak, red maple, and sugar maple. Now there's already a little tiny bit of these species here. Whoops. And the question is, will they become the dominant, or will there be any trees at all? And I'll show you what would determine that in terms of the climate in a minute. So Minnesota, as you already know, is the most interesting place in the world. And the reason for that is we have 3 biomes here: the boreal forest, which is the darker green, and then the temperate deciduous, which has maple, oak, and basswood species, and grasslands. We originally had 22 million acres of grasslands, which is all converted to corn. So I guess in a sense, it's mostly still grassland. Corn is a grass after all. So some of it's soybeans, I guess. But anyway, 3 biomes come together here. And the only other place where this happens is in Kazakhstan, at the southern edge of the Ural Mountains. So very interesting place. It means we have a lot of edge. Edges of different vegetation types respond more to climate change than if you're in the interior of a biome, and we have a lot of edge. We are the edgiest state in the union. And here's what they look like. This is boreal forest at Tetagouche State Park. And this is all balsam fir and white spruce and paper birch in this particular picture. Here's a temperate deciduous forest, sugar maple, basswood, and red oak from southeastern Minnesota. And all that lush greenery you see there is wood nettle. And I've spent doing a lot of field work in wood nettle. So if you don't get stung by the insects, you get stung by the nettles. And then here's a prairie. We still have 1 or 2% of our prairies still remaining, and this is what they look like. So for potential futures in a warmer climate, it could look like this, or it could look like that temperate deciduous forest up here in northeastern Minnesota. So my graduate student, Nick Fisichella, for his PhD project, I sent him out in the forest and I said, you figure out what makes the difference between temperate forest and boreal forest. So he visited all of these places, and they all have some temperate and some boreal trees growing side by side. And up by Grand Marais, it's 95% boreal and only 5% temperate. And out by Bemidji, it's the opposite. It's almost all temperate and a few boreal trees, but they were all growing next to each other. And then he was able to look at the growth rates of the saplings that represent the future generation and did both the ring width, in other words, the diameter growth, and also the height growth of these. These 5 species are shown in this slide: balsam fir, white spruce, red and sugar maple, and red oak. And here's what he found, that there's a summer temperature gradient. It says 17 to 19 Celsius. I'm not sure if all you are on the metric system. That goes from about 64 to about 68 degrees Fahrenheit mean summer temperature. And summer temperature is way more important for tree growth than winter temperature. They're dormant in winter. They don't care if it's 20 below zero or 60 below zero. And the height growth, as you can see, has a crossover point, which is right around 65 to 66 degrees Fahrenheit, where temperate and boreal trees grow at equal rates. But if it gets warmer than that, the temperate trees will grow more. And if it gets colder than that, then the boreal trees will grow more. So if it warms up and you started out with the colder summers here and it warms up to the warmer summers, you could be in a position where the boreal trees will grow faster and be able to outcompete and replace the boreal species. And we found in our surveys of all of those locations on the map that where temperate and boreal forests are next to each other, the temperate trees are invading the understory of the boreal forest. So with the little bit of warming that's already occurred, there's already a shift underway. And you notice that in the boundary waters, there's more red maple around than there used to be. And here's an example of a local temperate boreal ecotone, Oberg Mountain, on the ridge above the north shore of Lake Superior. And you see in this early October picture, the sugar maple temperate forest in red, and the boreal forest in the lowlands. And of course, you should be aware of the fact that temperature and elevation works backwards in Minnesota, because Minnesota is upside down. The lower you go in elevation, the colder the climate. And that's true in summer and winter, and that's due to cold air drainage settling into low areas. So there you see the boreal forest in the valley and the sugar maple on the ridge. So we are upside down compared to the rest of the world, where when you go to higher elevation, it gets colder. So we're the edgiest state, and we're also upside down. And here's a place, this is in Wisconsin actually, but they also have the ecotone between boreal and temperate there. And in 1979, I was here and you could not find a maple tree anywhere. And so I go back in 2016, this was, and look at that sugar maple tree there. So just a little bit of warming has been enough to let that tree enter the boreal forest. So that was Nick Fisichelli's work. He got his Ph.D. several years ago. He's now the director of the Schulich Institute in Acadia National Park in Maine, and hosted a meeting with Deb Haaland, the Secretary of the Interior, accompanied by a cello recital by Yo-Yo Ma, which is absolutely amazing. Although I have really good students, I'm not surprised if they do better things than I ever did. Then we have the prairie forest border. What determines whether there will be trees, any trees at all, whether they're boreal or temperate versus grassland? Well, I assigned that to Nick Dons, a PhD student. And he's now a professor at University of Wisconsin-Superior. And so this shows the original meaning time of European settlement, forest versus prairie in Minnesota. And it turns out that that was very much related to the water balance. So if you look at precipitation and evaporation, wherever there's more precipitation than evaporation, which is green and blue in the map on the right, there's a positive water balance, and that's where the forests are. And then when you have more evaporation than the precipitation in the extreme western part of the state, that's where you get grasslands. So if in a warmer climate, the evaporation goes up more than precipitation, you could end up with a rainier but drier climate. So how about that for an oxymoron? And so this just summarizes those two studies. When the water balance is around 0, that's where the prairie forest border is. And it's all about summer temperature, whether you get temperate or boreal forest. So we thought, what about putting this on the map? So we divided the whole Great Lakes region into 1 square kilometer, which is something like a third of a square mile in area, 300,000 grids, and looked at the climate of each of those and then assigned them to one of these biomes in terms of what vegetation type the climate there would create. And that's the map on the left here. And the boreal is in blue. And you see that's into northeastern Minnesota and ends right about Ely. The green is boreal temperate mixture. The yellow is temperate deciduous, so maple, oak, and the brown is prairie, is grassland. So that's what it is right now. And then the question is, what about the future? We could take the future projections of climate for a low warming scenario and a high warming scenario. And those are the 2 maps on the right. You can see for the low scenario, if we actually followed the Paris Agreement or the agreement from Scotland a few years ago, we would have that scenario and Minnesota would still look like Minnesota. The biomes would move a little bit because it would warm a little bit, but it would still look like Minnesota, whereas the high scenario or business as usual, Minnesota does not look like Minnesota. Almost all of it would be a prairie climate, all of that. And you'd have oak and maple here in northeastern Minnesota and on some of the big hills in the driftless area on the north sides, according to our models. And then you have that huge area that would, that would be prairie right there. And so if you took Kansas and like stood it up and moved it, it would fit right in that area. That's brown. And so I was talking to a reporter from, let's see, the Washington Post, and he was asking me about it. And I said, well, we have a perfectly good Kansas. Now we don't need a second Kansas in Minnesota. And he ended up putting that in the first paragraph of a front page story in the Washington Post. So I found out what it's like to get real feedback because the Washington Post is read around the world. And what I discovered is half of the people in the world think I'm an idiot and half of the people think I'm a brilliant scientist. So I'm okay on average. But it's true, we don't need another Kansas in Minnesota. 1 Kansas is sufficient. So looking at analogs, one thing you can do is you can look at an area like the boundary waters and ask, where is a place that right now, instead of looking at a projection for the future, find a place that right now has the same summer climate as the boundary waters might have in the future. So I did that, and that's Granite Falls, which is the orange star. And the only difference is about 8 degrees Fahrenheit mean summer temperature between those 2 locations. They both actually have granitic rocks. They have similar rocks, similar chemistry, similar physiography of the landscape as the boundary waters. And that's why it's called Granite Falls. And so here's the boundary waters. This was on the title slide, black spruce growing on 2.8 billion year old granitic rock. And here is nice outcrops natural area near Granite Falls, 3.6 billion year old granitic rock here. And you see scattered oak trees with prairie-like vegetation in between. And again, 8 degrees summer temperature is the only difference. The soils and the physiography are pretty much the same. And that's why I chose to model things based on summer temperature several slides ago. The same in Europe. My friends at the National Academy of Sciences of Poland invited me to work on this study to map out where their major tree species would grow in a warmer climate. So I gave the keynote address at their National Academy of Science annual meeting, got to visit their castle that they own and paged through this book about 8 inches thick. That was the first known flora of Europe. It has like 4,000 plant species, and every single page is a hand-painted painting of a species of plant. And I said, don't I have to put gloves on to touch this book? And they said, no, you're the guest of honor. You can do whatever you want. I did not take it home. No, I was very respectful. I mean, it was one of the greatest works of art. It's one of the greatest works of art that exists anywhere in the world. And only a handful of people ever get to see it because it's in the rare book room on the 3rd floor of a castle in the middle of the Polish Academy of Science Arboretum. Anyway, so we did this work with the main tree species, one of which is Norway spruce, and the map on the left shows in green where it grows today. And the red is where it grows today, but would not grow for the high warming scenario. So you would see much of Europe would lose one of its most important tree species, and the same for Scots pine. Together, these two trees are the major forest forming tree species of all of Central Europe, and they would all be lost. In Europe, and the margin of the boreal forest would also move way far north there. So the same situation is here. Okay, so how do we get from one forest type to another, or one biome to another? And this is where the concept of the legacy lock comes in. So a legacy lock means you have disturbances and the forest bounces back afterwards to the same type, right? Like jack pine burns in a forest fire, comes back as jack pine, burns again 100 years later, comes back as jack pine. Jack pine has a legacy lock on that site. And what does it take to disrupt that? Well, for jack pine, they survive disturbance in the form of seeds. The seedlings die, the adult trees die, only those serotinous cones that are opened by fire, the individual trees or potential trees in the form of seeds are what survives. And therefore they can survive one high intensity fire after another for thousands of years and have a legacy lock. But if you get 2 intense fires in a short time, so the trees aren't old enough to have cones, at the second fire, that legacy is broken and it can switch to birch and aspen. And that is starting to happen in the boundary waters. Red and white pines survive disturbance as mature individuals. They don't have stored up seeds. The seedlings are killed in fires, but the big trees have thick bark that insulate them, and their foliage is so high above that it doesn't get scorched very much. And repeated surface fires are their disturbance regime that maintains their legacy lock. So a high intensity fire with an understory of balsam fir, for example, would break that. And we're seeing that happen in a few places. The balsam fir and cedar forest type, what survives are seedlings and saplings. Again, no stored seeds, and wind is the disturbance regime that favors that. And it knocks over the big trees, but the little trees are the same species and they just grow up. So as long as you just get winds, it's fine. It's only intense fire that breaks their legacy lock. So there's patches all around the boundary waters with these different regimes. Did you know the white and red pine forests live in areas where the physiography of the landscape interrupts the flow of fire, so you don't get as many big high intensity crown fires as you do on sites with jack pine, where the physiography of the site facilitates flow of high intensity fire across the landscape, like the area where the Pagami Creek fire was, for example. The lakes are small and the land area between the lakes is pretty big. And here's a red pine. It can burn like that for, in case you remember what I said 2 years ago, it can burn like that for about 25 minutes before it kills the living tissue under the bark. It's that good of an insulator. And there is Mrs. Heinzelman. 9 years after that fire, with the regeneration of the red pine, and the big trees are fine. They have some char on the bark, but they're fine. Frequent burning by indigenous people maintained the old multi-age red pine stands, and in fact allowed them to become more old growth, like bigger trees, longer live trees, because they burned them every several years, and that kept the balsam fir out. So when the big wildfire came, it was not that intense in those red pine stands. And of course, they did that to grow blueberries in the understory, and blueberries are not extremely flammable. So that maintained a legacy lock for red pine in scattered locations throughout the boundary waters that were their preferred sites for thousands of years. They managed red pine stands for 7, 8, 9,000 years, and knew what it took to make a legacy lock for red pine and keep it that, because that was an ideal place for them to live. And then here's the high intensity large fires that you get in jack pine, completely different regime, but that's what jack pine is adapted to. And here's a jack pine forest after a high intensity fire with 100-foot high flames. 5 years later, it's all jack pine again. The legacy lock is intact. But if you get 2 burns in a short time, the legacy lock is broken for jack pine. And you get aspen, or if there's never a fire, right? Because the cones might never open. This is a 190-year-old jack pine stand, and you see cedar, those kind of olive green trees along the shore, coming in 190 years after fire. And the legacy lock is broken by too little fire, so it can be too much or too little for jack pine or red and white pine. And of course, wind disturbance complicates these legacy locks. This is the 99 blowdown, the extent of it starting near Ely here and going all the way to the Gunflint Trail. And it started in Fargo. Did you know that? Lots of good things come out of Fargo. And it crossed all the way to Maine. By the next morning, the storm was all the way to Maine, but it reached its maximum intensity right over the boundary waters with 120-mile-an-hour winds for about 20 minutes at any given point. Well, what happened to some of these stands? The jack pine stands actually diverged into spruce, cedar, or fir, depending on what was in the understory, because those were released from suppression when the jack pine blew over. So the pine lost their legacy lock in the big blowdown, and we had conversion to spruce, fir, and cedar. And here's a 200-year-old red pine stand. This is on 3 Mile Island in Seagull Lake. You can see the spruce and the cedars in the understory there, and there it is after the blowdown. And see that tape there? They did a prescribed burn there, and here's the exact same tape after the burn. And guess what that did? Blowing it down, so the cones were down in the fire instead of up in the canopy. The seeds were all killed, and 4 years later, the regeneration is all paper birch. So wind plus fire breaks the legacy lock, and that's true for all conifers. And it converts to birch and aspen. And this is happening throughout the boreal forest, throughout the world, in Alaska, in the boundary waters, in northern Sweden, in Russia, all across the boreal forest. It's one of the early impacts of climate changes to switch from a conifer boreal forest to a deciduous birch and aspen, still boreal, but much different type of boreal forest. And here's a wind plus fire. This is on Seagull Lake here, and there's pin cherry coming up there, and all that birch that I showed you. So 7,000 years of jack pine dominance was finally broken by wind followed by fire. So the big difference from the historic regime is the legacy lock of boreal conifers is increasingly being lost to either too much fire or wind followed by fire. And this is up on the Gunflint Trail on the Magnetic Rock Trail. that goes off to the side, off to the east, up near the tip of the Gunflint Trail. And this was all conifer before the fire. And as you can see here, it's almost all birch and aspen, except for a few conifers down in the valley there where there was some seepage and it was wetter there. So you don't need to look at all the details on this slide. It's just enough for me to summarize it as saying the classic successional pathways, or I should say non-successional pathways that Heinzelman found, jack pine to jack pine, white pine to white pine. In other words, the trees were in sync with the disturbance regime and they just maintained dominance. There really was no succession, which means a change in composition. Whereas now, with multiple fires in a short time, or wind plus fire, no matter what you start with, red, white pine, jack pine, balsam fir, black spruce, or white cedar, you end up with aspen and birch. Everything is converging on aspen and birch now. And then you throw earthworms in. And this is a picture of a balsam fir, and look at the exposed roots there. They would never have exposed roots like that, but the earthworms ate the forest floor, which had been 6 inches thick accumulation of leaf litter, leaving the roots exposed. And so last summer, I was dealing with this reporter from the New York Times, and she was doing an article about earthworms and how they're invading boreal forests throughout the world and even the tundra now. And I developed this figure for her. You change the climate, you change the forest to birch and aspen. The worms love the birch and aspen, so they move in, and then they change the nutrient status of the soil. The nutrients leach out and go in the water. You get eutrophication of the water, CO2 emitted by them eating the forest floor, and then you get impaired water quality, wildlife habitat, and less carbon storage on the landscape. And she said, "What the heck is this?" And she decided to publish this picture instead. She thought that this picture was worth 1,000 words or 1,000 arrows on a diagram. However, I was able to put this in the book chapter that I showed you at the beginning. So it still got used. And then if you look at the legacy lock at the biome level, you can stay as a boreal forest of conifers. You can switch to boreal birch aspen, or you can switch to temperate deciduous forest or no forest to a grassland or savanna, or you could plant a totally new ecosystem. You could plant Austrian pine, for example, throughout the boundary waters, and it would grow here no matter what the climate did, especially if you got the seed source from Greece or Italy. So here's northern Minnesota before the big blowdown, well, before and after. And there we are walking around after, and you can see all those shade-tolerant conifers that were released from suppression. When that blew down, it stayed conifers, but what about now? Some of the boreal stands look like this, and all the red you see is red maple that has gone into the understory. So if it blows down now, it's an instant transition, not from pines to spruce and fir boreal forest, but from boreal forest to temperate forest in an instant, literally. So wind, when you have boreal understory trees, it's just a boreal forest with smaller trees afterwards. But wind, when you have that invasion in the understory of temperate trees, which we are getting in the boundary waters, wind can change the biome. I mean, I showed you how it could change the forest. Now I'm showing you how it can change the biome. Yeah. No, the wind just pushes the big trees down, and the younger trees then grow and fill that space. And we all know about droughts. Have you seen any dead birch trees on the North Shore in the last 20 years? About 30 million of them. And that helps release temperate trees as well. And we know that droughts can actually kill forests. This is a forest, this picture is taken in July. The forest is actually dead from a drought, and this is out in Alberta and Saskatchewan. And then we have insects. When trees are under drought stress, they can't resist insects. and you get these major infestations that can cause landscape level change. So it's not just the legacy lock from changing disturbance regime that I showed you, but disturbances when new tree species have moved in, and disturbances caused by insects that can now have two generations in a single summer instead of just one, and they aren't killed as much in the winter by the cold. So you end up with insects as a much more important disturbance. They've always been here and have always killed a few trees, but they can do it more massively in a warming climate. So now things are accumulating, right? From what I've said, there's a lot of ways to kill a boreal forest, and the most spectacular way that we found so far, which I'm just getting to now, is phenological disturbance, where the timing of the trees coming out of dormancy of the spring is not aligned with the new climate. So the March of 2012, it was 70 degrees at mid-March, almost all the way to Hudson's Bay, and it was in the 70s here in northern Minnesota. In mid-March, the trees came out of dormancy and then froze. Even though boreal trees are the most cold resistant trees, ironically, if they come out of dormancy too early, they can be damaged. And this is one of our plots in the boundary waters, jack pine and balsam fir that turned brown, and they did recover. And the spruce forest on the bottom near Thunder Bay, by May, they turned brown. They did recover using stored energy from the root system, but if this happened 2 springs in a row, it would kill the whole forest and could potentially kill the whole boreal forest from here all the way to Newfoundland. If we ever get 2 springs like the spring of 2012 in a row, that's my prediction. Phenological disturbance, meaning mismatch of timing. So droughts, insects, phenological disturbance, they can also cause legacy loss, just like fires that come more often, or wind followed by fire. So a lot of different types of disturbances are adding up. And how big could the conversion be? Well, on this map, you see this dark black line, which is the boreal forest right now, coming through northern Minnesota. All of this area in the brown could, with a warmer future climate, convert to grassland. And all of this area in the yellow could convert to maple and oak forest. And notice Minnesota is right at the hinge point, so we would get some of each, depending on whether you're at the tip of the arrowhead or over here in the western part of the boundary waters. An area of forest 5 times the size of Minnesota, or 2.5 times the size of Japan, because I gave this presentation at Hokkaido University. So I threw Japan in there because they don't know how big Minnesota is. But Minnesota is pretty big, but 5 times the size of Minnesota of boreal forest converted to a different biome is a potential thing that could happen before the end of this century. And the future temperate forests won't even be the same because of the earthworm invasion and the high deer population and all sorts of other things as the old temperate forests that we were used to. Okay, then the last thing I'm going to do is talk for a minute about the 45 million acres that burned in Canada last summer. So this graph shows the annual area burned from 1983 to 2023. So the red bar on the right is 2023, 45 million acres, 2.6 times as big as the previous record of 17.5 million acres in 1995. So this indicates that this thing about more frequent fires could be a real thing. Believe it or not, Canada is so big that 45 million acres is only 5 or 6% of all the forest in Canada. But still, if that much burned every year, it would all burn in 20 years instead of in 100 years, which was the historical average. And this shows all the fires over a 30-year period in Canada. So in 2023, 5% of all the forest, compared to 0.6% in a normal year historically. So the big fires might make this big change in biome. The phenological might do it, the insects might do it, the droughts might do it, they all might work together and do it. And then future big fires in Minnesota, This is a map showing increasing risk of big high intensity fires in the future. The dark red is are places where it's projected to have a 600% increase in big high intensity fires. And you might notice one spot on this map with the dark red. Yeah, we expect a lot more big fires in Minnesota. It doesn't show that in California because they already had their 600% increase, and that is gradually creeping east. And so we've had these big fires recently in Minnesota. And does that take us back to the historic regime? Because is that an early sign of changing climate? If you look at the before European settlement, we had a 122-year average cycle for any one spot to burn. That went to 2,000 years during the 1900s because of exclusion of fire. And now we're back to about a 100-year cycle again. And is this a step towards a very short fire cycle that would convert to a savanna, or is it just going back to historical normal? And I'm just leaving that there. Invite me back in 10 years and I'll have the answer. So we don't know whether it's a return to historic or whether it's a step on the way to a much higher frequency of fire than we had in the past, and therefore conversion to birch and aspen and savanna. And so the conclusions, disturbance regimes are changing in all these complex ways I just talked about. Historical legacy locks that persisted typically for 7,000 to 9,000 years are being lost. Extensive changes from conifer to deciduous boreal forests are underway everywhere, and transition from boreal to temperate and or grassland are likely to occur in some areas. So with that, if there's time, I will take some questions, and thank you for listening.
Right, Mr. Boyle.
If I understand you, you were saying frequent burns in the past. They eliminated a lot of the unwanted trees and benefited the climate. Then I'm assuming cultural burning and frequent burning disturbs the ground fire.
Yeah, the frequent burning by indigenous people would have reduced leaf litter and the balsam fir layer under the pines. And that's why when the big fires came, they would drop to the ground in that area and be less intense. And that's why they were able to take refuge there.
So then with the advent of earthworms, the disturbance of the leaf litter had a more disastrous.
Yeah, it's going too far.
Too far.
With
it's
the
matter of.
Yeah, it's going too far and making the soils drier and droughtier because there's no protection. Yeah, so you can have duff that thick, and that's kind of bad. That thick is really good, and that thick is bad again. There's like an optimum amount.
Okay. This is all very sobering information.
There's good news for people who like prairie plants. There's good news for people who like birch and aspen. And I like birch and aspen. I don't think they have to be the whole landscape, but I do like them. Well, the good news is that all of this stuff that I showed in the last half of the presentation might not even happen if we go on the low emission scenario. So that's what we have to do. And we know that from all the research I've done. If we do that, all these changes will be very minor instead of major.
How do our ash trees fit into this story?
Oh, ash trees. Boy, that's a good question. Right now, in this area, it's too cold for the emerald ash borer. If you hit 40 below zero a couple times each decade, they can't really get established. You might remember it was 50 below or colder in 2019. So they're protected by that extreme cold. And the question is, will that go away in a warming climate? And if it does, the ash trees will die. And what will probably take their place under natural conditions would be balsam poplar, which is the tree you smell when you drive up here from the Twin Cities and you open the car door and there's that northwood smell. That is balsam poplar. And it does grow in those swampy areas. It's not quite as good a competitor as ash, but if you get rid of the ash, then it's free to enter those areas. So in Door County, Wisconsin, where my cabin is, almost all the ash have died, and balsam poplar are filling those swamps now. Whoops.
You mentioned a scenario where Ely might become more like Granite Falls. How much temperature change would it take to make that swing?
Yeah, about 8 degrees Fahrenheit in the summer, and probably about the same in winter. Yeah, so 4 degrees Celsius or 8 degrees Fahrenheit. Yeah, and that's not quite the maximum, not that upper scenario, but it's close to it. So it's substantially more than the low scenario that I showed.
If western Minnesota becomes Kansas, what happens?
Yeah, if western Minnesota becomes Kansas, then Kansas becomes Arizona. And Arizona becomes I don't know what, because if it's 150 degrees, I'm not sure what would live there. I'm not sure there is anything that could live there.
Did you reference the Oscar? Yeah. Right here, is there any effort to plant for those?
We know it survives here because it's used as an ornamental. But the question is, do you want to have a whole landscape of an exotic tree species that won't support the wildlife and the native insects and so on, like our native pines would, or would you rather have native species that are different? And there's no correct answer to that, you know. But if you have to have a savanna because that's the way the climate is going, then you might as well say, let's make it the best savanna that it can be and not have it be a bunch of buckthorn, but have it be native plants. But you could always plant Austrian pine. It will grow anywhere.
You distinguish between balsam poplar and aspen. Can you distinguish anything between quaking aspen and big-tooth aspen, or are they synonymous?
Yeah, the question's about big-tooth aspen versus quaking aspen. No, they're not synonymous. Big-tooth aspen is near the northern edge of its range here. It's way more heat and drought tolerant. So my prediction is it will increase in abundance at the expense of quaking aspen as the climate warms. Yeah, and then our third species of aspen is the balsam poplar. A lot of people don't even realize that it is an aspen species, and it has all that sticky goo, and it makes it hard for their equipment when they try to make it into paper, but they do use it. And it has those thick leathery leaves, and then has that really nice smell, but it is an aspen species. It's a very odd aspen species. And it goes almost all the way to the Arctic Ocean in the north. Incredibly cold tolerant, incredibly swamp tolerant. It's an amazing tree. It grows on sand dunes, tops of sand dunes and in swamps, and in areas that are really hot and in areas that are like right at the edge of the Arctic Ocean. It's hard to figure that species out, but it's good to have mysteries out there.
You haven't talked about the biggest disturbance prior to climate change, and that's the old growth logging and then the continuous hobble logging in the area.
Yeah, so the question about the logging of the original old growth, yeah, so in most of the Midwest, aspen and birch forests were pretty rare because there weren't windstorms. Windstorms followed by fires did not affect a big area. And then the European settlers came along and they logged the whole landscape and burned the slash. So they took a disturbance type that was extremely rare and made it cover the landscape, basically. And that's why we ended up with birch and aspen from Maine all the way to Minnesota. But half of the boundary waters was never logged and still is pretty close to natural. And as you go north, most of the boreal forest hasn't been logged, although they're logging it rapidly now in Canada, but there's still huge tracts of unlogged forest throughout the boreal biome and throughout the world because it's the hardest place for people to get to. So yeah, it is true that we had that big disturbance and the forests were just recovering from it. And they were going back to what they were originally because we didn't wipe out the ecological legacy in that logging, because a lot of it was done in the winter, and a lot of the microbes in the seeds were left intact under the snow. So there was enough legacy around the landscape to make it all recover to what it was before European settlement. But now climate change could permanently upset that balance, whereas it was a temporary effect from the settlement.
I have another Granite Falls and Boundary Waters question. If I remember correctly, the surface of the boundary waters, the wilderness itself is about 20% water. Would that have any impact at all in that comparison? The fact that there's that much surface water?
Yeah, the question is about surface water and does that matter? And yeah, it matters. I mean, with more evaporation in a warmer climate, lake levels might go down. So some shallow lakes could become wetlands and some wetlands could become dry, and deeper lakes will become warmer. But
I was thinking, excuse me, I was thinking of the other way. Would the presence of that fresh water have some kind of tempering effect on temperature?
Yeah, oh, would it have a tempering effect on the temperature change? Yeah, for the inland lakes, very little. It's more in fact, lakes, when you're away from Lake Superior, the small lakes probably actually have a net warming impact because they absorb a lot of solar radiation, and the water temperatures get quite warm compared to Lake Superior, whereas basins that don't have lakes but have bog instead are much colder than the rest of the landscape. Yeah, and then when you get to Lake Superior, it's a whole different thing. Lake Superior is cold and it'll probably always be cold because it's such a massive volume of water. And the climate models don't take the Great Lakes into account. When I made those biome maps and those changes, I had to go into the climate data and change it by hand to reflect the presence of the Great Lakes. So that tells you how important the people who develop these worldwide data sets think the Midwest is. They can't even take into account the effect of Lake Superior in their data.
Wow.
Well, there have been some pieces of this that I've talked to them about in the past, to the DNR and the Forest Service, little pieces of it, but it was just when I wrote this book chapter that I pulled it all together like this, and I have not presented the pulled together version other than here at the Chickawauk Museum on Sunday and the Minnesota Native Plant Society last October. Just those three have seen this pulled together overall summary.
We have a question from Zoom. How might restoring a mixed fire regime via managed fire impact future scenarios?
Okay, so mixed fire regimes are regimes where you have surface fires that sometimes flare up into intense fires, so it's not one or the other. And you can look at that. Is it a mixed regime from one fire to the next at one spot, or is it a mixed regime across the landscape where some places have surface fires and some have high intensity? So it's both spatial and over time. And yeah, mixed regimes are great because they give you a little of everything and they allow for a maximum amount of diversity in the response of the ecosystem. So I think it'd be a good thing. It's hard to do on a prescribed fire basis because people don't like to light anything that's more intense than, say, a 3-foot flame, which has an energy intensity output of about 500, whereas a boreal forest fire has an energy intensity output of about 50,000. You know, a big crown fire with a 100-foot wall of flames, you're talking about 50,000 kilowatts per meter, compared to the prescribed fire with a 3-foot flame that has 500 kilowatts per meter. So that amount of energy in that natural fire is so gigantic, it's bound to have a much different impact on the ecosystem. That's actually what most of the boreal forest is adapted to. as long as it doesn't come too often.
Question back here.
I want to thank you for totally informative, enlightening presentation. But I am totally depressed and saddened. As you know, yeah, well, you know, the dinosaurs are extinct, supposedly surviving, supposedly a few birds. I guess, has anyone addressed the impact on birds and other animal life? Have you shared that with others?
Yeah, there are studies of the impacts on birds. The Audubon website, in fact, has projections of these maximum forest change scenarios for every bird species in North America. So yeah, birds in particular have been studied. For mammal species, it's more about it old for young conifer, old deciduous, young deciduous, or shrubby or savanna-like is like the most important. It's more the structure and which species of trees are there. So you can project which species would do better or not as well for any future scenario, as long as you can map it out on the, see how much would be in vegetation. And no study has done every mammal, but there's a lot out there.
Before I give the microphone to ask a question, I'll just say that next week's Tuesday program will be provided by Joe Friedrichs, the author of a book called Last Entry Point. And last question.
Thank you. On my property, all the birds and so forth are dying, and I left. And so I'm planting other conifers. Should I be doing something different to fill in those spaces?
Yeah, the question is, the birch is dying and it's going to conifer, so it's going the opposite of the big trend worldwide. That the birch are too old and they die and the conifers underneath grow. Replacing it, trying to get red and white pines in there is fine if that's what you're planting. And once those get big, you might want to remove the balsam fir from the understory so that you get a system that's more resilient to fire so that the big pines are able to continue to grow. Okay.
I cry when I have to remove those 60 foot balsam.
Yeah. Yeah, well, you don't have to get rid of every balsam fir tree, right? They always exist. Having a few, especially that are further from buildings, is fine. Yeah, and they will torch up in a fire, and it's what, but it wouldn't be a contiguous crown fire. It would be what we call a passive crown fire, where it's on the ground and occasionally torches up. Yeah, you don't have to cut down every balsam fir. It shouldn't be an extermination campaign against any native species.
I lied, I have one more question. I know that your work as a scientist doesn't necessarily involve advocacy, but I do wonder, knowing what you know, what do you think should be the most prioritized topic as it relates to advocacy and the health of the forest, regardless of how it evolves?
Yeah, what's best for the health of forest, regardless of how it evolves. Let's see. So that's basically like a 40-hour-long answer. But I would say overwhelmingly keeping CO2 emissions low and stabilizing the chemistry of the atmosphere has to be the biggest priority, because if we don't do that, anything that you do will be out of sync with the climate a few decades later, and that will just keep going on and on. But locally, saving all old growth forests, because they store a lot of carbon, trying to get the average forest age a little bit older, trying to keep the deer population in balance. Things like that are the best things you can do as a forest management activity locally. But we have to do the global thing for CO2, and unfortunately, everybody on the planet is in that together, and there's no way to get out of that. All
Join
right.
me in thanking Lee Frelich.
All right.